we go. All right, so part 4 of our situation here, of our summary and application, it's going to be putting it all together. So being able to analyze your stretch, your compressions, your shifts, left, right, up, down, all that good stuff, okay? And so here we are as far as how that goes. So in your notes, you should have a book that summarizes all of your actions. So as you look right here, it says what's happening. So if I have a function plus or minus d, that's going to cause it to go up and down. If I have a function plus or minus c, that's going to cause it to go left and right. And so remember, our x's are liars. So even though it looks like it's plus c, it's actually going to the left. Even though it looks like minus c, it's actually going to the right. Okay. And it tells you what you're doing if you're making a table. So what's happening to the values on the table. Okay. Here are our reflections. If it's a negative on the outside of the function, it's a reflection over the x-axis. That's because you're multiplying your y's by a negative. Okay. If it's a negative on the inside with x, that means you're reflecting over the y-axis, and that means you're changing all of your x's. And then we have our A. A is our stretch, our vertical stretch or compression. If the absolute value of A, that means regardless whether it's negative, right? If absolute value of A is greater than 1, you have a vertical stretch. That means you're multiplying your y values by that amount, okay? If your A value is between 0 and 1, you have a vertical compression. That means that you are still multiplying by that value, but it's a fraction, which means that you also may be dividing, right? Because 1/2 is the same thing as dividing by 2. And last but not least, you have your horizontal compression and stretch. It's the opposite. You have a compression if your absolute value of your B is greater than 1. And you have a stretch if your absolute value of B is between 0 and 1. And again, our x's are liars. So it looks like multiplication, but it's actually what? Division. You're actually multiplying by the reciprocal. Okay. And so
yeah, I'll make sure that real quick.
Okay. So that's what's happening. Putting it all together. And so like your do now, you had an example of multiple transformations happening, right? In our notes, we just looked at single transformations. Now part 4, yeah. We're going to look at multiple transformations. So it says here, find the function that is finally graphed after the following sequence of transformations are applied to the graph of y equals x squared. Okay. So the first thing you want to do is to identify what variable are you talking about. So if I want to shift right, what variable am I describing here? It's going to be my horizontal, right? So that means that it's going to have to be whether you call it. So if you look on the chart, notice here in some textbooks it's called C, and ours is called H, just because it's our vertex. But in some textbooks it's called C, and they just go by A, B, C, D. So C is your horizontal translation, D is your vertical translation. So if I want to shift right 3 units, that's going to be my C variable, right? And that means that C equals, it's going to look like a -3 because our x is a what? A liar, right? And I want to reflect about the x-axis. So if I want to reflect about the x-axis, is my negative going to be on the inside or is it going to be on the outside? Outside. So if I want to go over the x-axis, that means it's my A. And that means my A has to be a negative. So if you're not following along or not. So if I want to reflect over the x-axis, that means that it has to be the negative on the outside. So my A is what's on the outside. So A has to be negative. Okay. If I want to shift down 2 units, so I want to shift down 2 units, that's going to be my D, and I want it to go down, so it's going to be a -2. So now I'm putting it all together. So my new function would be y equals negative x minus 3 squared minus 2. That's because here's my A, my C, and my D. I went right 3, I reflected, and I'm going to go down. Okay, there's no B here. There wasn't a y-axis reflection or any horizontal compression or stretch. Questions, comments, concerns?
I'm concerned about my grades. Other than that.
All right, well, about this?
So do we need actual graph for this?
No,
Oh,
the answer is, it says, what's the function? So here's your function.
okay.
So this is the function that if I graph it, it should have done all 3 of these things, right? It should have shifted to the left. It should have reflected, and it should have gone down 2 units. So by that, what that means is if we, it's going to pull up the calculator to show you. I'm going to go back to y equals. Second plus 712. All right, so I'm going to go here, and it says your original is x squared. So my original function is x squared, which is just the parent function for the quadratic at the origin, right? And we want to do the things that were listed. So if I have done this correctly, when I graph this, all things should happen. So we have negative x minus 3 squared minus 2. It's important that you keep the attributes of the function. So that square has to be there. Otherwise, you're just graphing a linear. So when I graph, here's the parent function. And then here's my transformation. Did it go to the left? I mean, to the right? Yeah. Did it go down 2? Yeah. Did it reflect over the x-axis? Yes. So everything was applied and changed. Okay. All right. Okay. So next here, it says describe the graph of the function h of x equals 1/2 x squared plus 1. Okay. So first thing you want to think about is, what is your parent function? If I'm 1/2 x squared plus 1, my parent function has to be the quadratic. Does that make sense? So the original, your f of x is x squared. That's my parent function. Okay, so that means the values here, so the parent function, that's our -3, -2, -1, 0, 1, 2, 3, because these values aren't going to change for the parent function. And we're at 9, 4, 1, 0, 1, 4, 9. How did I get those values? Well, I plugged it into the parent function. What is -3 squared? 9. What is -2 squared? -1 squared? 1. These are the same values every single time for your parent function. Okay. So notice here it says 1/2 x squared plus 1. All of these things are outside of the x, outside of the parent function. Does that make sense? So all of this is outside of the parent function. And because it's all outside of your parent function, that means you have a equals 1/2 and your d equals 1. So all of these are going to do is change your y variables. Am I touching x?
No.
No, there's nothing inside with x. It's just x squared. I'm not moving x, okay? So when I am graphing this, I'm changing all of my y values. So to my y values, I'm going to multiply because it's a compression by 1/2. And then I'm going, or just divide by 2. And I'm going to plus 1, which because it's going to shift it up. So when we look what's happening here, we have a vertical compression by 1/2. And then we have a vertical shift up 1. Yes, because that's the values that are being given. So again, so we have, this is our V compress, and this is our vertical shift. And again, vertical is affecting your y. So I'm going to take 9, and I'm going to 9 divided by 2 plus 1. 4 divided by 2 plus 1. 1 divided by 2 plus 1. 0 divided by 2 plus 1. 1 divided by 1, divided by 2 plus 1. 4 divided by 2 plus 1. 9 divided by 2 plus 1. Probably should have did that in a different color. Okay, so now 9 divided by 2 plus 1 is going to put me at 5.5. 4 divided by 2, huh? It's going to put me at 3. 1/2 plus 1 is 1.5. 0 plus 1 is 1. And then they're going to repeat, right? Because they have to be what? Symmetrical, because it's quadratic. And they have symmetry. So now my new points are at -3 and 5/2. So I can go -3 and 5/2. I'm going to count these as half marks. So I'm going to. So hopefully they'll get me. So I go to -3. 1, 2, 3. And I'm going to go up to 5/2. Well, that's going to take me off. So 1, 2, 3, 4, 5. It's going to take me off the board a little bit. There's 5/2. I'm going to go to -2, 3. So go to -2, go to 3. I'm going to go to -1, 1.5. So -1 at 1.5. I'm at 0, 1, 0, 1. And I'm going to repeat on the other side because they are symmetrical. Okay. So now describe the domain and range here. What's the domain? The graph goes forever to the left and forever to the right. So what's your domain? Infinity, negative infinity, positive infinity, all real numbers. Okay, what's your range? Range is from bottom to top. What's the lowest my graph goes? What is my lowest y value? Just +1. I go all the way down to +1, and then I go up to infinity. So my domain is y is greater than or equal to 1.
Yes.
I think so. Remember, I don't make our tests.
Well, yeah, but you know, like the format.
I don't see the test until y'all start. Yeah. Yeah.
No essays, right? That's how I was saying.
Probably not. All right.
Wednesday.
Wednesday. All right. So that is it.